Welcome to Utility Locating Training by Brian Moss from RJM Equipment Sales. If there is a single sound source, then it is easy to hear the loudest location and it will be closest to the source. If there are two speakers, but only one of them is on, then it's still easy and accurate to determine the source of the sound. If there are two speakers near each other, then it will be harder to locate each one. The combined sound of both will be the loudest in between and not closest to either. Voltage is like water pressure, forcing more flow through the system. Higher pressures force more water to flow. Higher voltage pushes more signal through the circuit. Small wires are like small pipes resisting flow. Partially closed valves are like dirty or rusty electrical connections, reducing flow. Opening a valve is like cleaning a connection. Signals traveling from the ground stake are like pumping water through a small particle filter. Electrical resistance, like dirty connections and dry soil, make it harder to get a good signal. Locate signals induce into other nearby utilities like radios, transmitting signals. Close, large, parallel utilities induce more signal. Transmitter signals travel by conductivity and by inductance. The amount of signal traveling by conductivity depends on the combination of voltage and resistance. Signals induce more at high frequencies. The total signal is the combination of both. If other utilities are nearby, use the lowest frequency that is strong enough to locate. High frequencies cause more signal on other utilities, causing more errors and more signals to identify. The combination of signals are unlikely to be the highest when closest to your target utility. Choose the lowest usable frequency for the best accuracy. Utility isolation is safer. If you can ground the far end of the tracer wire, the locate signal can return to the transmitter ground rod through soil conductivity. This makes the signal stronger, allowing you to use a lower, more accurate frequency. Lower frequencies induce less, making it easier to identify the same signals. 512 Hz will often work. Removable ground connections for better locates to far end without needing to find the ground at the far end. Water mains such as cast iron and ductile iron with gaskets insulate signal from traveling by conductivity from one pipe section to the next. Frequencies must be high enough to induce into the next section. 33 kilohertz normally works best and travels the farthest. Try 8 kilohertz if less induction into nearby utilities is needed. Low frequencies travel well on pipes like galvanized steel and copper because the connections have low resistance. Use a high power output on the transmitter because the outside is not insulated, allowing the current to leave the pipe quickly. Increase the output setting on the transmitter, up arrow on a radio detection. Improve the ground. You can do this by cleaning the connection, use a nearby independent ground, use multiple ground rods, jumpered together. Wet the ground rod, longer ground rod at the angle to limit maximum depth. Clean connections on the utility, ground the far end, increase the transmitter voltage. The last choice is increasing the frequency. Radio detection transmitters can be increased from low voltage setting, 30 volts, to high voltage, 90 volts, to increase the signal strength. In this example, the signal increased from 1 milliamp to 7 milliamps by raising the voltage. High frequencies start stronger, but get lost faster because more signal is induced off of the utility as it travels away. Low frequencies begin with lower strength because less signal travels by induction, but it remains more constant since less is lost from induction as it travels away. If you stand in place and tip the locator sideways, the signal changes, but you haven't moved. If the signal is getting weak and bouncy, move the locator side to side and watch for trends. In peak and null mode, the maximum signal is when the locator is facing down the utility. The locator displays the minimum signal when perpendicular or 90 degrees to the utility. The compass line remains parallel to the pipe or cable even when rotating the locator. Radio detection locators include a strike alert feature, which warns you when a power line or other utilities are less than 12 inches away. You can prevent accidentally hitting lines by using this feature. If a power line has a voltage but no current, it does not create a signal to locate. The current or load provides the signal defined with the locator. The transmitter is not needed. The power signal will be stronger if the current is increased. In areas with underground power, all other metal utilities usually have a power signal. If a power line has a voltage but no current, it does not create a signal to locate. The current or load provides the signal defined with the locator. The transmitter is not needed. The power signal will be stronger if the current is increased. In areas with underground power, all other metal utilities usually have a power signal. If a power line has a voltage but no current, it does not create a signal to locate. The current or load provides the signal defined with the locator. The transmitter is not needed. The power signal will be stronger if the current is increased. In areas with underground power, all other metal utilities usually have a power signal.
The RD8100 PDL and RD7100 PL have individual power frequency modes. This helps find individual cables better instead of a group of cables. The compass and arrows help guide. Push the antenna button while in the power mode to switch to a single frequency mode. If you push the power button again, it will switch to the next single frequency.
If a power line has a voltage but no current, it does not create a signal to locate. The current or load provides the signal defined with the locator. The transmitter is not needed. The power signal will be stronger if the current is increased. In areas with underground power, all other metal utilities usually have a power signal. Metal utilities are antennas collecting radio signals from the atmosphere. No transmitter is needed. Metal utilities are antennas collecting radio signals from the atmosphere. No transmitter is needed. Passive modes can save time by locating power and radio signal at the same time. Some metal pipes have signals applied to prevent corrosion of the pipe. Some locators can track these pipes without the transmitter, providing an easy way to identify and/or avoid them. Where's the best place to stick your rod? Choose a location where there's no other utilities between the ground rod and the utility that you're locating. Utilities between the ground and the target line will have a stronger signal, increasing the errors when locating near it. If other utilities are found after you begin to locate, reposition the ground. Placing the ground rod in the direction of the locate increases the signal. Connecting to a chain link fence that's close to the utility can cause multiple signals. The signal will be strong, but not isolated. Grounding to a structure which is also grounded can produce multiple signals. The signal returns on every conductor that shares the same ground. By connecting to two places on the same utility with an extension wire, all of the signal travels through only the wires and target utility instead of the soil. All frequencies will be strong, and a very low frequency can be selected for better isolation and accuracy. The jumper wire on a reel is an electrical coil which blocks frequencies. Move the jumper wire away from the target line. Even wires are much better conductor than dirt. Start locating by circling all the way around the transmitter to find all the signals. Then identify each one so that you don't assume it's the wrong one. Connecting to isolated point and working towards congested area of utilities helps identify and isolate the target signal.
When using an induction clamp, no ground is needed. Make sure the clamp is closed all of the way. It's excellent for non-contact applying a signal. Because the clamp is made of iron inside, clean the contact points when rusty with steel wool. Check that the clamp is completely closed to get the best signal.
Signals can be applied with induction clamps. The higher the frequency, the more signal is induced. Larger pipes and cables will collect stronger signals. Radio detection transmitters prevent frequencies below 8 kHz when using an induction clamp because the signal would not be strong enough. To test an induction clamp, choose a frequency that is in the hearing range and available when an induction clamp is plugged into the transmitter, and set the transmitter output on high. 4 kHz, 8 kHz, and 9.8 kHz will work. If you hear a high-pitched hum near the clamp, the transmitter is working. Try flexing the cable near each end while listening.
Direct connection leads and induction clamps are a better choice than induction from the transmitter. Place the handle parallel to the pipe or the arrow parallel to the utility.
If the signal increases when you point the locator at the transmitter, some of the signal is directly from the transmitter, so you're too close. Another test is to rotate the transmitter 10 to 20 degrees away from parallel to the pipe and check for peak signal in front or behind the transmitter. When you're inducing from the transmitter, very little control of where the signal goes is available. It does not identify well which is which. By placing the transmitter on its side, you can reduce the amount of signal in the utility directly underneath it. Radio detection locators have up to 6 combinations of antennas: guidance mode, differential peak, null, single peak, peak and null with arrows, peak with guidance arrows. The peak, dual peak, or differential peak is the upper horizontal antenna signal subtracted from the lower horizontal antenna. The dual peak antennas are affected the least by nearby signals. Have the most confidence in the dual peak mode. The null signal is from the vertical antennas.
The null signal displays a minimum in the center and increases on each side. A different signal on each side indicates errors. The null signal changes rapidly as you move away from the center, making it easy to find the center. The null antennas can be the most precise way to find exactly the wrong spot. Because the single peak or broad peak antenna does not have the upper antenna signal subtracted from it, and because it's closer to the utility, it's more sensitive than the dual peak. Broad peak accuracy is better than null, but not as good as the dual peak antennas. Use the broad peak antenna when you need a stronger signal. The broad peak signal is indicated by the bar, percentage, and the tone loudness. The horizontal arrows show the guidance arrows. The arrows are short when you're closer to the center. To switch to the peak with null arrows, hold the antenna button for 2 seconds, or it can be changed in the menu. The guidance arrows are more accurate than the null arrows. The peak signal is indicated by the bar, percentage, and the tone loudness. The horizontal arrows show the null arrows. The null arrows are the farthest away, making the easiest to compare to the peak to determine if there are errors. The guidance mode, continuous tone on the left, no tone in the center, and a pulsing tone on the right make it easy to follow. The sensitivity is automatic, and there are left and right arrows to guide you. Center the gap to become center over the utility. The guidance arrows are better than the broad or single peak, much better than the null antennas, but not as accurate as the differential peak. It's more sensitive than the peak, and the gain is automatic. To check the accuracy, compare the peak signal position to the null signal position. If they agree, then the accuracy is good. If they're different, then you have errors. The guidance is almost as accurate as the peak. When the peak and null are in the same place, there are no other signals nearby, all of the antennas have zero error and locate in the same place. If you are locating in a bend, the signal from one section interacts with the signal in another section, causing errors. If you're in the peak mode, the signal will indicate inside the bend. In the null mode, the signal will show outside the bend and farther away from the actual location. If you're locating in a bend using the null mode, the signal can be as much as 20 inches outside of the actual pipe. If you're locating in the single peak mode, the indication can be as much as 15 inches inside the actual pipe. With the dual peak, the signal can be as much as 9.5 inches off on the inside of the peak.
To determine when you have errors, when the peak, null, or guidance mode indicates a different location, you can isolate the signal better to improve the accuracy and get them to show the correct location and eliminate the errors. If you can't eliminate the errors, you can estimate the actual location by taking half the distance between the peak and the null and estimating on the other side of the peak from the null. To give yourself greater confidence that you and the locator are working properly, find an isolated utility in a straight section, such as one that's exposed, and locate it and see if they agree. You can also check the depth in this way. Sometimes the challenge in locating is not finding your utility, but finding out which one is which when you have multiple signals. You can do this by locating the other utilities first to eliminate which one is yours. You can use a ring clamp around other utilities to get access. To check and see if your depth measurement is accurate, place the bottom of the locator on the ground and then raise it by a known amount. If the depth reading changes by amount that you change the height, then your depth reading is accurate. When you're measuring depth with the locator, it's to the center of the pipe or cable. To determine if your transmitter and your leads are working, connect them together and listen or read the output levels on the screen. You should have a nice high output like 200 milliamps and a low voltage, indicating the locator and the leads are working well. Sometimes you might want to try flexing the connections near each end, because those are the areas that get used the most often. When you're locating, use all your clues. Go by the locator signal. Also look for above ground information like valve boxes, pedestals, hydrants, meter boxes, transformers, junction boxes, trenches, light poles, trench depressions. Also as-builts, memory of when it may have been installed, and try and avoid assumptions. A sonde is a battery-operated transmitter that fits in pipes and conduits. It creates a strong peak directly above the sonde when horizontal, that is 5 times stronger than the other peaks. Find at least 2 peaks to confirm the center, which is the strong peak. In peak and null mode, the left and right arrows when locating the center confirm the receiver is in the sonde mode. Some locators include a current measurement display, which can help you identify which utility is which. The milliamp reading in the lower left corner when measuring the depth is the signal strength. The utility with the strongest signal is the utility that the transmitter is connected to. Induced signals can't be stronger than the original. Shallower utilities can have a higher percentage because it's closer to the locator. The current, or milliamp, reading compensates for the differences in depth. Check the depth accuracy to determine if the current reading is correct. Identify the same utility that the transmitter is connected to by comparing the current reading for each utility. The transmitter is connected to the utility with the strongest milliamp reading if the depth readings are accurate. Some locators include a current direction feature that is very useful for identifying when you're locating the same utility or for locating which utility is which. When the arrow is forward and you're facing away from the transmitter, you are locating the same utility that the transmitter is connected to. Current direction, or CD, works even when depth measurements are not accurate. To check the current direction, verify the direction arrow at a known location, such as the very beginning. If you're locating a utility that the signal is being induced into from the original signal, a backward arrow is displayed. If the arrows are incorrect in the beginning, the current direction needs to be reset. Either hold the F button for 2 seconds or choose the current direction reset in the menu. Current direction can identify if you have begun to follow the wrong signal. After long distances, the current direction could need resetting. Current direction is included on the radio detection PDL and TX10. Use the lowest frequency that provides a usable signal for the best accuracy. Compare the peak and no locations to verify locate accuracy. Compare the changes in depth reading to the changes in depth measurement to determine if depth measurements are accurate. Compare current readings or current direction to verify the correct utility. Thank you for joining me for
Questions.
Please let me know if you have any questions. I hope this has been helpful.